Hello dear students, let us solve some numerical problems related to Bohr's theory of hydrogen atom. At first, let us review the related formulas. Energy of electron in nth orbit of hydrogen atom is given by En is equal to minus 13.6 electron volt upon n square. When an electron is transmitted from or gets a transition from first one orbit to another orbit, then the wavelength of photon emitted is given by the relation 1 upon lambda is equal to r into 1 upon n1 square minus 1 upon n2 square, where r is Rydberg constant. Its value is this much. And in the spectrum of hydrogen atom, as you know, there are different series: Lyman series, Balmer series, Parsons series, bracket series, etc. So for the Lyman series, n1 is 1 and n2 is 2, 3, 4 dot dot up to infinity. Similarly for Balmer series, n1 is for Balmer series, n1 is 2 and n2 is 3, 4, 5 dot dot up to infinity, and so on for other series. Now, energy of photon due to transition may be calculated from this formula. Delta E is equal to E initial minus E final is equal to HF, where H is Planck constant, F is frequency, or equal to Hc upon lambda, where c is velocity applied. Now, ionization potential of hydrogen atom is given by the relation E infinity minus E1. Radius of nth orbit is directly proportional to n square, and velocity of electron in nth orbit is inversely proportional to the square root of radius. Now first numerical is calculate the energy, momentum, wavelength of photon emitted from n is equal to 3 to n is equal to 1 of hydrogen atom. First question. Solution to question 1. Here we have n is equal to 3 to n is equal to 1 transition of hydrogen atom. At first we can calculate the wavelength. So start with the third part. You know 1 upon lambda is equal to r into 1 upon n1 square minus 1 upon n2 square. Here n1 is lower state and n2 is upper state. So this is 1.097 into 10 to power 7 into 1 upon 1 square minus 1 upon 3 square. On simplification, this gives wavelength lambda as 1.025 into 10 to minus 7 meter. Now come to the second part. Lambda is equal to h upon p from de Broglie formula. Lambda is equal to h upon p. So we have to find the momentum. Therefore, momentum p will be equal to h upon lambda. H is 6.625 into 10 to minus 34 divided by lambda. Lambda is 1.0 0.025 into 10 to minus 7. On simplification we get the momentum as 6.46 into 10 to power minus 27 Newton second. And now come to the first part. We have to find the energy. Energy E will be equal to hc upon lambda. H is 6.625 10 to minus 34. C 3 into 10 to power 8. And lambda is 1.025 into 10 to minus 7. On simplification we get the energy as 19.39 into 10 to minus 19 joule. And when it is divided with 1.6 into 10 to minus 19, it gives energy in electron volt. It will be 12.1 electron volt, which is 19.39 into 10 to minus 19 divided by 1.6 into 10 to minus 19, which is 12.1 electron volt. Question number 2. Calculate the shortest and longest wavelength of Balmer series. Solution to of question 2. For Balmer series, N1 is 2 and N2 is 3, 4, 5 dot infinity. Therefore, when the transition is from second to third orbit, it will give longest wavelength, and when the transition is from 2 to infinity, n is equal to 2 to n is equal to infinity, it will give shortest wavelength. So when n1 is 2 and n2 is 3, then wavelength will be longest. Then 1 upon lambda, longest or maximum, will be equal to Rydberg constant into 1 upon 2 square minus 1 upon 3 square. Rydberg constant is 1.097 into 10 to power 7 into 1.4 minus 1.9. On simplification, it gives lambda maximum as 6.563 into 10 to minus 7 meter. Now, when the transition is from n is equal to 2 to n is equal to infinity, means this transition will give lambda minimum and this will give lambda maximum. Next, when and when n1 is 2 and n2 is infinity, then wavelength will be shortest. Then 1 upon lambda minimum will be equal to Rydberg constant 1 upon 2 square minus 1 upon infinity square, which is 0. So R into 1 upon 4 minus 0, which gives R by 4 means 1.097 into 10 to power 7 by 4, which gives lambda minimum as 4 divided by 1.097 into 10 to power 7, which is 3.646. 3.646 into 10 to minus 7 meter. And third question is, to what quantum number the hydrogen atom in ground state will be excited by absorbing a photon of energy 12.75 electron volt. Here electron of hydrogen atom is in ground state. Ground state means 1. And we have to find n2. Energy of photon absorbed is given as 12.75 eV, which is suppose HF. Now E n2 minus E n1 will be equal to energy of photon HF E n2 minus 13.6 eV upon n2 square, E n1 minus 13.6 eV upon 1 square is equal to, this is 12.75 electron volt. 12.75 electron volt. So we get, this becomes positive 13.6 eV minus 13.6 eV upon n2 square is equal to 12.75 eV, which gives 1 upon n2 square is equal to 13.6 eV, or EV can be cancelled out. 13.6 upon n2 square will be equal to 13.6 minus 12.75, which gives 0.85 EV. Is 0.85. Therefore n2 will be equal to under root 13.6 upon 0.85 under root, which gives 4. So n2 will be 4, means electron must be excited to the 4th orbit. Now question number 4. The first member of Balmer series has wavelength 6563 angstrom. Find the wavelength of second member of Balmer series. Now solution. For first member, Balmer series, N1 is 2, therefore 1 upon lambda 1 will be equal to Rydberg constant 1 upon N1 square minus 1 upon N2 square, and N2 is 3. So this is 1.0, or simply R. This is R into 1 upon 2 square minus 1 upon 3 square, which is R into 9 minus 4 upon 36, means 5 upon 36. Question 1 suppose. Similarly, for second line of Balmer series, N1 will be 2 and N2 will be 4. Therefore, N upon lambda 2 will be equal to R into 1 upon 2 square minus 1 upon 4 square, which gives R into 3 upon 16. Question 2. Question 1 upon equation 2 gives lambda 2 upon lambda 1 is equal to RR cancels out, and 5 upon 36 into 16 upon 3, which is 20 upon 27. Therefore, lambda 2 will be equal to 20 upon 27 lambda 1, which is 20 upon 27 into lambda 1 is 6563 angstrom. On simplification, we get 4861.48 angstrom. Thus, the wavelength of second member of Balmer series will be this one. Next question. Calculate the wavelength of electromagnetic radiation emitted by a hydrogen atom which undergoes a transition between energy levels of 136 into 10 to minus 19 joule to minus 5.45 into 10 to minus 19 joules. Planck constant is given to be this much. So E1 minus E2 will be equal to HF or HC upon lambda. Here value of H is given, E1 and E2 are given. Therefore, lambda will be equal to HC divided by E1 minus E2. H is 6.6 into 10 to minus 34. C is 3 into 10 to power 8. E1 is minus 1.36 into 10 to minus 19 is common to both. So we can take it common. minus this one, minus 5.545. So we get 6.6 into 10 to power minus 34 into 3 into 10 to power 8 upon 5.45 minus, this becomes plus, minus 1.36 into 10 to minus 19. On simplification, we get wavelength as 4.841. 4.841 into 10 to minus 7 meters. Next question. Calculate the energy that must be given to hydrogen atom so that it can emit second line of Balmer series. For solution for Balmer series, N1 is 2 and N2 is 3, 4, 5 dot dot infinity. So 2 to 3 will be first line and 2 to 4 will be second line. This will be the second line of Balmer series. Therefore, for second line of Balmer series, N1 is 2 and N2 is 4. This is second line. Therefore, 1 upon lambda will be equal to Rydberg constant 1 upon N1 square means 2 square minus 1 upon 4 square which is R is 1.097 into 10 to power 7. LCM is 16. 4 minus 1 means 3 upon 16, which gives lambda as, on simplification we get lambda as 4862 4862 and to 10 to minus 7 meter. Therefore, required energy will be equal to Hc upon lambda. H is 6.625 into 10 to minus 34. C is 3 into 10 to power 8 upon lambda. 4862 10 to minus 7, which comes to be 4.087. 4.087 into 10 to minus 22 joules. 22 joules, or in electron volt it will be 4.087 to 10 to minus 22 divided by 1.6 into 10 to minus 19 electron volt, which comes to be 2.55 into 10 to minus 3 electron volt. Next question number 7. Calculate the wavelength of radiation emitted when electron jumps from fourth to second state of hydrogen atom. Solution here. N1 is 2, N2 is 4. Sorry. We have to find the wavelength. Now 1 upon lambda will be equal to R. 1 upon N1 square means 2 square minus 1 upon N2 square 4 square. R into LCM is 14. 4 minus 1, which is 3 by 4. 3 R by 16. 3 R by 16. 1 upon lambda, which gives lambda as 16 by 3 R. 16 upon 3 into R is 1.097 into 10 to power 7. On simplification, we get the wavelength as 4861. 4861.4.7 into 10 to minus 7 meter. Next question number 8. An electron of energy 20 electron volt comes into collision with the hydrogen atom in ground state. The atom is excited to a higher state and electron is scattered with reduced velocity. The atom subsequently returns to the ground state by emitting a photon of wavelength 1.216 into 10 to minus 7 meter. Determine the velocity of the scattered electron. Mass of electron is given this much. Now, let us understand this question with a diagram. Suppose this is ground state of hydrogen atom, and this is an electron which strikes the ground state of hydrogen atom with energy 20 electron volt, which is 20 into 1.6 into 10 to minus 19 joule, that is 32 into 10 to minus 19 joule. The hydrogen atom is excited to a higher state. This is excited state, and subsequently it emits a photon of wavelength lambda is equal to 1.216 into 10 to minus 7 meter, and this striking electron comes to or gets scattered. Scattered electron with velocity v. We have to find the velocity of scattered electron. Now from the law of conservation of energy, in this case, energy of striking electron will be equal to the energy of emitted photon and plus energy of kinetic energy of scattered electron. That is, Ek will be equal to Hc upon lambda plus half mv square. We have to find v. Therefore, first we separate it out. Half mv square will be equal to Ek minus Hc upon lambda. Therefore, v will be equal to under root 2 Ek minus Hc upon lambda divided by m. Therefore, v will be equal to under root 2 Ek is 32 into 10 to minus 19 minus H is 6.625 into 10 to minus 34. C is 3 into 10 to power 8 upon lambda 1.216 into 10 to minus 7 whole divided by mass of electron 9.1 into 10 to minus 31, and on simplification we get the required velocity as 2.43 into 10 to power 6 meter per second.